Hello class, welcome to our lesson for today. It's section 2.2, which deals with trigonometric functions. And instead of just being numbers that are less than 90, this deals with angles that are all around the circle, for example, or all around the coordinate plane. The other thing is most of the things we're looking at today are, quote, exact value or non-calculator situations. So everything that we're looking at for this lesson and then also for the next lesson will deal with these scenarios. Now, before I start, if you know anything about the unit circle, you could use the unit circle ideas to help explain some of these things and find answers. I will say that for right now, you probably need to be able to explain kind of why the answer is what it is and be able to look at that. If you have no idea what I was talking about in terms of the unit circle, you're in luck because I don't really use the unit circle. The unit circle is just a big memorization tool. And when you start using a calculator with questions that aren't on the unit circle really doesn't become that helpful. So instead, I like to go with the route with the triangles and knowing positives and negatives and things like that. So I hope that you'll be able to grasp kind of the concepts today. So there's a lot of info, but I hope that it will go well for you and that you can get a good grasp of the material. The most important thing for today is to find what's known as a reference angle. A reference angle is always denoted with theta with a prime, with the one tick mark, and I'll always use that notation for my reference angles as I'm going through my lessons. It's going to be the positive acute angle, so it should be less than 90, that's made by the terminal side of the angle and the x-axis. So you'll notice there's four options for these things. In quadrant 1, okay, the reference angle is here. Quadrant 2, since the terminal side is in quadrant 2, it's from that downward towards the x-axis, as opposed to quadrant 3, which is upward to the x-axis. And then in quadrant 4, it's downward, kind of, think of it kind of like a negative angle look because it kind of goes in that direction. You need to know how to find these things in order to be successful on a lot of these sections. So that's what we're going to focus on today, is finding reference angles and then using them to apply to other situations. The first thing is to just find a reference angle. And the most important thing is to know what quadrant you're in. So 215 would be in quadrant 3 because it's higher than 180 but less than 270. And in order to find a reference angle in quadrant 3, it's always your number minus 180 because the idea is here's 180 and then the leftovers would be whatever the reference angle is. So you subtract that out and you get 35 degrees. The reference angle for the second one, it's in quadrant 2. 152 is in quadrant 2. And essentially you just go backwards. Okay, so you would do 180 minus 152 to figure out the reference angle is 28. In quadrant 1, it's just itself. In quadrant 4, you would do 360 minus because the whole way around the circle minus the angle would give you what's left. But you need to be able to find reference angles very quickly as you're looking at these scenarios. Okay, after that, it's finding what's known as exact value. Now, there are different ways to find these things. If you talk to other people, they'll tell you different options. I think this strategy works well if you're just learning it, and I think it's the easiest to quote-unquote memorize and use long-term. So what you need to know is here's the angle, 45 degrees. You need the reference angle. Well, 45 is in quadrant 1. The reference angle is itself. Then what you need to deal with is the 30, 60, 90, or 45, 45, 90 triangle that we dealt with in the previous section. So I'm going to try to draw those things out on each page. And the two things I need are the triangle that matches the reference angle and the all students take calculus because that'll tell you what's positive and negative. When I find these answers, I'm just going to use the reference angle to find the ratios, and then I'm going to use the plus minus ideas from all students take calculus, and that will answer everything. On all of the questions we're looking at today, I'm only going to find the three main ones, sine, cosine, tangent. Obviously, you would find reciprocals for the other three, cosecant, secant, and cotangent. So just realize that I'm only writing the three down, but you may have to find all six. So 45 degrees for a reference angle. Here's 45. SOHCAHTOA. Okay, sine is opposite over hypotenuse, so opposite is 1 over 2. Rationalized, root 2 over 2. The nice thing about 45 degrees is sine and cosine are the same because they're opposite and adjacent are both 1. And then tangent would be opposite over adjacent in that case, which would just be 1 over 1 or 1. All positive because I'm in quadrant 1. The next question is 315. So that angle goes all the way to quadrant 4. What you need is the reference angle. It's 45 because 360 minus 315 is 45. Technically, this is a triangle in quadrant 4 where x is 1, y is negative 1, and r is root 2. But I could just use the reference angle and say, okay, it's a 45-degree reference angle. That's the same triangle. Notice my answers are all the same. Root 2 over 2, root 2 over 2, 1. But since I'm in quadrant 4, cosine's positive, but notice I just slapped on a negative sign for sine and tangent. The reason is because the y value is negative. Okay, but you can kind of shortcut that if you have this idea, and you can use the SOHCAHTOA methods. Every 45-degree angle is going to have these same ratios in every quadrant. It's just which ones are negative. So you're really not learning anything new with that. It's just setting it up and figuring out what the relationship between the numbers are. The next one is 150. So 150 is in quadrant 2. You need the reference angle. The reference angle is 30 degrees because 180 minus 150 is 30. That's the important step. Then I'm going to use the 30, 60, 90 triangle. 30 is my angle, so opposite over hypotenuse is 1/2. Cosine, adjacent over hypotenuse, 3 over 2. And tangent is opposite over adjacent, which is 1 over root 3, which I rationalized to root 3 over 3. Now notice, sine is positive, and I just slapped on negative signs because the x value, or cosine, and tangent are negative in quadrant 2. But notice, I didn't have to necessarily figure that out at that moment. I could do that at the last moment to be able to figure out the answers for the 6 trig functions. This one's 1500. You can basically just subtract 360 until you see what's left. So I keep subtracting 360, 360, 360. It ends up being the same as 60 degrees in quadrant 1. So my reference angle is also 60. You'll notice I flipped this triangle around. You could use the same 30, 60, 90, but you have to make sure you go from 60 for SOHCAHTOA. If you would rather have 60 in the bottom left corner, you could just use this triangle instead. So sine would be opposite, which is root 3 over 2 for r, or the hypotenuse. Cosine 1/2, tangent root 3 over 1. All positive because I'm in quadrant 1. And again, I know this is new for a lot of you, but the key is figure out what quadrant you're in, figure out the reference angle, use the reference triangle, and then figure out what's positive and negative. Negative 855. If it's a negative angle, remember you're going the opposite direction. But essentially, I just kept adding 360 until I got to a positive, and that's going to be 225. Here's a little hint. If it's an exact value and ends in 5, the reference angle is 45. I can't ask you any other. There's no other perfect triangle that works well for us. So that means all of these root 2 over 2s are showing up again. But since I'm in quadrant 3, notice that sine and cosine are negative, but tangent is positive. So the only issue is the negative signs. So it ends in 5. You know the reference angle has to be a 45. And then the issue is what's positive and what's negative. Negative 390. Notice I went around the circle one time backwards. And then there's 30 degrees left over, which puts me here. So the reference angle is 30. The other option is you keep adding 360 till you get to a positive. The reference angle is 30 degrees, so I'm going to use the 30, 60, 90 triangle. And it's in quadrant 4, so notice my cosine value is positive, but sine and tangent are negative. That's the only difference. And if you've learned the unit circle, I think this is a little bit easier to understand and actually know what you're looking at instead of just memorizing a bunch of stuff. Okay, we're using the same information we've already learned before to be able to find that answer. Okay, these two are just review questions. I'll leave them to you to make sure you know what to find. The one thing I will say is don't forget when you do secant, just use SOHCAHTOA with cosine and then flip it. That's going to be easier for you to work on. But if you have questions on this slide, let me know, and I'm happy to look at it with you. Same thing here. You'll notice that you got 45 degrees, so that's an easy reference angle. These two here on the right, you're going to have to use those zeros and negative ones because they're quadrantial. So the questions that I can ask you with are 30s and 60s with the 30, 60, 90 triangle, 45s with the 45, 45, 90 triangle, and then these quadrantial angles, which are 0, 90, 180, 270, etc., where you have to kind of use the x and y and r ideas. But they should be zeros, negative ones, ones. You notice this cotangent one is undefined, for example, because zero's on the bottom. Those are typically the hardest ones to remember because they don't match the triangle as well. For these evaluating questions, honestly, we have bigger things to worry about to make sure that we understand right now. So if you're asked about any of these questions, you could just plug them into your calculator. The one thing I will bring up that will be important later on is if you see this like sine squared, like this sine squared here, that really means it's sine of the number to the second power. What mathematicians have done is they don't want you to confuse if you should square the number or square the sign of the number. So they put the square inside like this to represent the same things. But if you plug into your calculator, it's going to have to look like this to make sure that you don't square the number. And you want to make sure you find sine of 225, then square. So it's something to keep in mind for questions like this. The next question is similar to a homework style question that you might see. It's find the coordinates of a number. Essentially, it's here's the ratio, or here's the reference angle of 45 because 225. Just make a coordinate plane, and then 225 is in quadrant 3. They give you R, and what you could do is kind of like the last section where you kind of set up the ratios and see the relationship between them. So what you could do here is just do the x over 10. So x is the short side, 10 is the hypotenuse, equals a 45, 45, 90 triangle. The short side is 1 over root 2. Cross multiply and solve. Don't forget you have to simplify here. 10 divided by 2, it becomes 5 root 2. The x value is 5 root 2, but it's negative because you're going backwards. So the only thing you have to make sure of when doing this is that you go in the right direction. So negative 45. And then, or I'm sorry, negative 5 root 2. And then the nice thing about 45, 45 is if you found x, you found y. So just be careful on the negatives and the positives as you're looking at that situation. Okay, we're going to end with this question. Now, this is one of many, so the next lesson will have a lot of these styles of questions. This is going backwards. So what this is telling you is here's the ratio, find all the answers that work. And typically there's going to be 2 answers because there's 2 spots around the circle that work. So here's my suggestion. We figure out the reference angle, figure out the quadrants, and then figure out the angles. So this says cosine is root 3 over 2. One thing you need to know is that cosine is positive then. And cosine is positive. Notice I circled A for all and C for cosine, quadrant 1 and 4. The second thing I'm going to do is just draw a triangle with my angle and then say, okay, well, cosine is adjacent over hypotenuse. Now, in the back of your mind, you have to say it's probably 30 or 60. I just have to know which one. So in this case, the adjacent is root 3 and the opposite, or the hypotenuse is 2. That corresponds to 1 being the opposite, which should correlate directly to that angle being 30 degrees. So 30 degrees is then my reference angle. I need to find the actual angles. So I just draw a reference angle of 30 degrees in quadrant 1 and quadrant 4 and then figure out what the actual angle is kind of in that blue color. So in quadrant 1 it's easy, it's itself. So the answer is 30 degrees. In quadrant 4, if the reference angle is 30, if I take 360 minus 30, I get 330. And what I want is the positive angle from 0 to 360. That's what this means. This is interval notation from 0 to 360. And so I want 330 as the other answer. There should typically be 2 answers for these scenarios. We're going to spend a lot of time on the next class period talking about these styles of questions. Your calculator kind of helps in some of these scenarios, but won't help entirely. So unlike some of the other questions where maybe your calculator can get you through for some questions, these ones will not. You need to understand all exact values if it's a non-calculator. Okay, it's going to be just as quick. You're going to understand things better, and then when you get to calculator questions, you're going to be better off anyway. So make sure you understand this process, and if it doesn't quite make sense now, that's okay, because we're going to be looking at it more in the next class period. Have a good day, everybody.